The James Webb Telescope keeps finding new galaxies that are simply too massive and too developed for their early stage of formation. And Lear Shamir from Kansas State University says if the Big Bang happened as science originally believed, then these galaxies are older than the universe itself. And indeed, Webb has now detected another structure that, according to our cosmological understanding, should not exist at all. Although the oldest known spiral galaxy existed just 1 billion years after the Big Bang, it's already fully mature. According to conventional wisdom, such a galaxy needs several billion years to reach this stage. But that's not all. In the same breath, an analysis of observations made by the James Webb Telescope has also suggested the almost unbelievable conclusion that our entire cosmos could be located inside a black hole. So, do we now have to say goodbye to our previous understanding of cosmic development? And are we really trapped in the heart of a bizarre gravitational monster? Be sure to stay tuned until the end to find out all the exciting details of the new Webb discoveries. Not all galaxies are the same. Astronomers distinguish between three main types, namely elliptical, irregular, and spiral galaxies. The latter make up around 70% of the galactic associations in the cosmos, and our Milky Way is also part of this group. Spiral galaxies are typically characterized by a dense central region known as the bulge, with a high density of stars, from which several long, curved spiral arms extend. Another typical feature is star formation, which increases from the center, where there are mainly old stars, toward the edges of the star disk. In other words, we're dealing here with extremely complex structures, and achieving this galactic complexity takes time. After their formation, galaxies initially resemble irregular clusters of stars, and the first flat disk of stars only gradually forms. However, it takes several billion years for the spiral arms and the central bulge to take shape, or at least that's what we thought until now. The James Webb Telescope has now added something to the star maps that should not actually exist. In the run-up to this, a team of astronomers, led by Mangwan Shirao from the University of Geneva, had been searching specifically for early bright galaxies as part of the Panoramic Survey, in order to gain new insights into their formation and evolution. And with good reason. Webb has already identified numerous galactic premature babies that are shaking our understanding of cosmic evolution. As mentioned at the beginning, these are the mysterious objects that appear far too large and star-rich for their age of a few 100 million years after the Big Bang. According to our understanding, there simply wasn't enough normal matter at that time to pave the way for such massive galaxies. And indeed, Shirao's team found what they were looking for, but in a very surprising way. Ultimately, the researchers discovered a spiral galaxy that existed just 1 billion years after the Big Bang and was unexpectedly large, massive, and highly developed. The impossible twin of the Milky Way. Named Zulong, which means torch dragon. This structure is about 600,000 light years across and contains more than 100 billion solar masses of stars. In other words, this early spiral galaxy is almost the same size as our Milky Way today. And Shirao sums up these remarkable parallels as follows. This galaxy is the best Milky Way analogy ever found in the early cosmos. It is strikingly similar to the Milky Way in shape, size, and stellar mass. However, it becomes even more remarkable when we consider that the twin of our home galaxy is already fully mature in its structure. Experts say that, unlike other massive early galaxies, Zulong already has an astonishingly advanced form. Not only does it have a largely inactive classic bulge, but also a star-forming disk and spiral arms that run through the entire galaxy. The bottom line is that this object is now the earliest galaxy ever discovered with these characteristics, and, at the same time, the earliest known spiral galaxy ever. And that is, to put it mildly, unexpected. Until now, such a complex mature structure in such early galaxies was considered simply impossible. Co-author Christina Williams from NOIR Lab in Arizona says it's generally believed that it takes billions of years for a galaxy to form these structures. Zulong now demonstrates that this can happen in less than 1 billion years. And as is now almost customary, experts are wondering how this confusing Webb discovery is even possible. What is certain is that the spiral galaxy must have evolved 10 times faster than today's galaxies in order to grow to its observed shape and size. However, what made this possible remains a mystery at this point, and astronomers can only speculate as to how Zhulong managed to break the usual patterns of development. The first vague assumptions refer to mergers with other early galaxies and developmental processes that no longer exist in today's universe. At the same time, researchers now hope to use the James Webb Telescope to identify other early maturing galaxies in the young cosmos in order to gather new, valuable information. They also emphasize that this unexpected discovery once again shows how dramatically Webb is changing our understanding of the early universe. And in fact, we may even be wrong about something much more fundamental. Are we living inside a black hole? Because this Webb discovery shows that the universe could be inside a black hole. At first glance, such a thought could not be more absurd. After all, black holes are considered monstrous omnivores, cosmic killing machines that literally destroy and irretrievably devour everything. And that is true. But at the same time, it's only part of the astronomical truth. On the one hand, black holes can easily be orbited by other celestial bodies in stable orbits, and they adorn the centers of virtually all galaxies. And on the other hand, we simply do not know what really lies within them. Well, unless your name is Nicodemi, and you are convinced that our cosmos was created in the heart of such a gravitational monster in the first place. In detail, the theoretical physicist at the University of New Haven assumes that the matter of black hole incessantly sucks and is compressed inside it until this is no longer possible. This creates a kind of cosmic seed, and the compression process eventually comes to a halt due to the insane rotational speed of black holes. And while the bizarre giant spins at nearly the speed of light, extreme torsional forces act on the seed inside, causing it to eventually burst open, triggering the much-cited Big Bang, or, in this case more likely, a big bounce. In other words, a black hole could thus embody the transitional state between two universes, something like a cosmic gate that can only be passed through from one side. Now, all this sounds pretty exciting, but also very far-fetched. So are there any concrete clues that make this idea more than just an unusual hypothesis? Well, surprisingly, there actually are. A research team, led by Luhr Shamir from Kansas State University, recently discovered something that suggests a groundbreaking theory. Specifically, the researchers analyzed more than 260 early galaxies in the so-called Jades field, which had previously been studied by the James Webb Telescope. Ultimately, the scientists concluded that the majority of galaxies rotate in the same direction. While about 2/3 of the structures rotate clockwise, only 1/3 rotate in the opposite direction. This is all the more confusing because this movement pattern stands in stark contrast to our fundamental expectations, namely that the rotational directions of galaxies in a random universe should be evenly distributed. However, since this is clearly not the case, approaches are needed to explain the galactic imbalance. Researchers are basically discussing two theories on this. The first is based on the assumption that the observation is simply due to measurement errors. More specifically, the so-called Doppler effect could cause galaxies moving toward us to appear brighter than those moving away from us. This could lead to a distortion in the measurements, ultimately making more galaxies appear visible in a certain direction of rotation than actually exist. The second theory, on the other hand, sounds a little more exciting. Based on Poplawski's thesis, it simply states that our cosmos originated in a black hole that already had its own rotation. According to experts, this idea is compatible with Schwarzschild cosmology, which postulates that our entire universe is the interior of a black hole in a larger mother universe. In this context, each black hole would represent the transition to a subuniverse or baby universe, while the rotation of the original black hole would influence the preferred direction of rotation of the galaxies in the newly formed universe. And Nikodem Poplawski also commented on this exciting hypothesis. Of course, he said, a preferred axis in our universe inherited from the black hole's axis of rotation could have influenced the rotational dynamics of galaxies and caused the observed asymmetry between clockwise and counterclockwise rotation. And even if the idea that we are all inside the belly of a black hole sounds strange, to say the least, it could ultimately be true. And we should not forget that the James Webb Telescope has repeatedly shown us that there are things in space that were previously considered absolutely impossible. It's also absolutely impossible that you'll ever miss a new video from us again if you click the subscribe button now. We'd love for you to join our community so you can stay up to date from now on. We'll see you soon.